batch students are here or not?
B batch.
B batch is here. Okay, we have merged labs today with B. That's why I'm asking B batch students. Okay. With you guys, till in practical number 7, we have completed 2. We have completed 2 practicals or 3. How many insertions are done in practical 7? Can you just see in the file and tell me? A batch I know. For B batch I just want to confirm. Students of B batch, kindly acknowledge till where we have done our practical number 7. We have completed all 3 insertions or just 2? All the insertions are done? Okay. And A batch, with you I have completed 2 insertions, right? So far. Yes or no, students of my A batch? Okay. So see, B batch students, till I lead batch A with your progress, what you guys do is open up your singly linked list file. Okay, the program where you have saved your singly linked list, the 3 operations. Insert at the beginning, at the end, and in between. Okay, I mean the ascending order. All right. What you guys do? This instruction is for students of B batch. Okay. Try to implement delete the first node of your linked list. Meanwhile, students of A batch, you need to have your attention here. We are going to discuss insert a node such that linked list is in ascending order. Both the batches instruction clear. B batch students, you are going to try out delete a first node in the linked list on your own by the time I reach with A batch there. Okay, then we will discuss. At that time, you can verify your answers with me. Okay. B batch students, work is already given to you. Start doing. Once I finish with A batch, I will call out random students from B batch to see what progress they have done. Okay. I don't want right answers. I don't want wrong answers. Please be very clear on that point. I just want you guys to code. Okay. I want to see how you are approaching the problem. Any doubt here in the instruction? Anybody? Pranjul, your voice is breaking. Okay. B batch students start working on delete the first node of the linked list. It is your task. Pranjal, you are from B batch. Okay. A batch students, attention here. We are going to first of all discuss this last insertion which is left. Okay, insert a node such that linked list is in ascending order. Okay, and then along with B batch, we will discuss delete first node of the linked list. Okay, everybody open up your previous file. Okay, so we have seen insert at the beginning function, display function is done, insert at the end is done. Okay, now we are going to do for insert in the ascending order. Let's discuss the flow. Okay, what we are doing here, insert node in ascending order. Okay, now what you have to take care, see here in your question it is said insert a node such that linked list is in ascending order according to the info field. According to the info field means what? According to the data field. Okay, the data which you are inserting in the node, that should be in ascending order. Okay, while you are placing the node inside your linked list. Now in order to do that, one constraint is here. The constraint what? The already existing linked list. Okay, the linked list which is already existing, it should be in ascending order itself, first of all. Okay, all right, so that is the constraint. So how we are going to approach, first step would be what? Your step number one, create the node, or you can say allocate the memory. If you understand by that, then allocate the memory. Okay, that is a step one. What is the step two? In your switch case, go and add the menu. I mean, add your user defined function. Okay, in your switch case. What is your user defined function? Some meaningful name, so that you come to understand that we have to insert into ascending order. Okay, that is your step two. What is the step three? Create that user defined function. Okay, create your user defined function here. All right, with some meaningful name. Let's say insert ascending. Okay, something like this. All right, now see what you have to do inside that insert ascending. Okay, inside this function, what you need to do, first of all, take, or you can say assign, okay, input for the newly created node. Okay, so what you are going to take as input? The data part. Okay, data part is what you are going to assign. So your printf scanf statement. All right, now D, what you are going to do next? You are going to check, okay, or you can say you are going to compare the data part of your new node, okay, and the data of your existing singly linked list. Fine. So how you are going to do that? You are going to compare it starting from your head node. So you can write here while new node data is less than temp data. Okay, we are going to take one temporary variable so that we can move that temporary variable, we can traverse it. Okay, head is not going to get traversed, but with the help of temp we are going to traverse it. Okay, and in order to traverse our temp, we are going to point it first of all at the value where head is pointing at. Okay, so temp equal to head and then this while loop. Okay, so if new data is less than temp data, or inversely you can also write that temp data is greater than new data. Okay, in inverse manner also it is going to be, checking correctly only. Suppose if you are not okay with this, then go with this one. Temp data is greater than your new node data. Okay, this condition is also valid. Fine. So out of this condition, whatever you are choosing, suppose I chose the first one there, that new node data is less than temp data. Okay, then what I have to do, sorry, greater than temp data. Okay, so traverse in your SLL. Okay, that is what you need to do. See, this we are discussing how the flow is going to work. Okay, so that's why I'm not writing very much technical codes here. Okay, wherever necessary I'm writing it in the steps, otherwise they are just statements for you to understand how the flow is going to work. Okay, fine. Once we reach a condition that new node data is no more greater than my temp data, okay, that means we have reached the required position where we have to enter our new node data. Then what you have to do, simply new node, because this is singly linked list, there is only going to be one link there. So new node of next is equal to ptr, or you can say temp. Okay, so you successfully inserted that in between. Let's see with an example here. Any doubt till here, anybody with the flow? B batch students, if you have missed anything, you can also concentrate here on what is going on. And even you guys are free to ask, okay? Okay, I don't have here. I am create one. Okay, this is my one node inside my singly linked list. This one is my another node, my third node, and my fourth node. Okay, and let me take arrows from here. link number 1 here, 2, 3. Okay, and one more. Okay, this is what pointed by your head. It has memory address of 100. My first node. Okay, my first node it is. See, even when you are preparing, you should also prepare something like this only. Okay. Let's say memory address, this one got was 118, this one got as at 0.90. Okay, and this one memory address is somewhere around 210. Okay, now see, our linked list should be in ascending order. So let's say 10. Okay, then here address would be the address value of next node. Okay, so 118. All right, I'm copying this here, here, and here. Okay, this is 18. This is somewhere around 24, and this is 30. All right, and my memory address is 90, 210, and null value. Okay, and this is my head, which is pointing at 100. Okay, now the very first step, according to our steps flow, what you have to do, allocate the memory for the node. Where you are going to allocate this memory? Not every time you are going to allocate the memory. You can do that here inside your insert asc udf program, function. Okay, inside that. So let's say you have created one node. Okay, this is my node here. All right, memory address, you used your malloc. Okay, new node equal to struct node star malloc size of that same function you are using. Okay, and here what is the memory address? Let's say it got memory address around 205. Okay, this part we have not yet given, new node part. The data part, let's say you are giving it around 20. Okay, so logically, if you see in your diagram, we come to know that it has to be placed between 18 and 24. Correct? Because we are going to compare this data part. Okay, and by that we come to know that this node is going to be in between here. So as we came to know that it is going to be in between here, so we know that now this 118, which is right now pointing at 90 here, we have to delink this, okay, in such a manner that it points to 205 and this 205 points to 90. Okay, that is our aim. Fine, so we will take one while loop. Okay, while your ptr is equal to head. Okay, so I'm going to take one ptr here, which is equal to my head. All right. So PTR is pointing at 100, memory address 100. So PTR of data. All right. 10. 10 is less than or greater than. You can choose any. Okay. But while you are choosing that less than or greater than, your program might differ with what I am explaining you. But do not worry, answer will be same. Okay. See, here what I have taken, new node data greater than temp data. Okay. So I'm going to write here it. New node I'm denoting it by n. Okay. New node data greater than temp I'm denoting it with t, temp data. Okay. So while my new node data is greater than temp data. Okay, so what is my new node data? 20. 20 greater than 10? Yes. So move my PTR. So I am going to move this PTR. Where I am going to move it? To the PTR of next. What is PTR of next? 118. So my PTR will be positioned here. Okay. Now again, 20 greater than 18. True. Right? So what I have to do? Move my PTR again. Okay, so I move my PTR again here. Again, third iteration. 20. New node data is 20. Greater than my temp data. What is my temp data? PTR. What is my temp? PTR. And data is 24. So 20 greater than 24? No. Okay, it is not the case. So what you are going to do? First of all, firstly, here you are going to update the value with the help of PTR. You are going to get the value here. All right. So new node next equal to 90. Okay. So what you did, you linked these two nodes. Okay. Because you gave here new node equal to PTR. Okay. So you linked this two. Now we have to delink these two also. Correct. We have to delink this, but unlike our doubly linked list, we don't have any backward links here, right? So what we have to do, we have to take one more pointer, okay, which will be one node behind this. Okay, so in your entire traversals, there will be two nodes. Now I'm not going to explain you again how that one node is going to be behind. We have already seen it in our theory sessions. Okay, so this is what it's going to be here. There will be one more pointer called pre-temp. Okay, with the help of this pre-temp, we are going to update this value. This 90 value we are going to update it. So pre-temp of next equal to new node. Okay, what is your new node? 205. So what we did, we delinked this two. Okay, now this link is pointing here. Okay, then you can check, see 10, 18, 20, 24, 30. So my single linked list is in ascending order. Okay, and they are pointing towards each other, so link is also correct, and the last one is having null value. Okay, any doubt here in the flow of the program or in the logic of the program? This was the logic. Any doubt here? B batch students, sorry, A batch students. Okay. See, from here, you are going to take two pointers, okay? We have seen traversal with the help of two pointers so far in the lectures, okay? Many times we have seen traversal where your pre-temp is one node behind, right? It is one node behind your PTR. Okay, so in this condition. This condition is the part of your while loop. Okay, new node data greater than temp data. Okay, or you can, if you want, I can write here PTR data. All right. So what I need to do if this condition is true, okay, if 20 is greater than my any given PTR data, then what I have to do? Wherever my PTR is, okay, that position I am going to give it to pre-PTR. So pre-PTR equal to PTR. Okay, and what should I do with my PTR pointer? It should move forward. Okay, so PTR of next. So if I go with first iteration, my PTR is pointing at 100. Okay, so 100 is the memory address. The data part stored by that memory address is what? 10. Okay, so new node, what is it? 20. 20 greater than 10. Okay, it is true. So what I need to do? My pre-PTR will be here. Okay, and what should I do with my PTR? It should move forward. So PTR will be here. Then in the second iteration, 18, okay, and 20. So 20 greater than 18, so it is true. So what I have to do? Move my pre-PTR. So pre-PTR is here. Pre-PTR moved next. Now it is 24. Okay, so 20 greater than 24, false. So we don't need to do anything. Okay, so now what is the position? Your pre-temp is here, okay, and your PTR is here. Now with the help of them, what we need to do? We need to delink this, okay. We don't need this link now because we want this particular newly created node to be inserted in between them, okay. So how the link should be from 10, 18, then 20, then 24, and then 30. Okay, so with the help of this pretemp, first of all, we are going to update this value. Okay, this value was previously pointing towards 90. That's why arrow is this side. Okay, now we are going to update this value. So pretemp of next equal to new nodes. So 205. So what we did, this link got moved. Okay, now it is pointing here. Okay, now we have to also create link between this new node and this PTR. So it is but obvious, new node next equal to PTR. So that is 90. Okay, so this link got created. Now you see 10, 18, 20, 24, 30. Last node is null. Okay, got it? Fine. Start doing. You already know the flow of the diagram. Here I have taken. Okay, this step. Okay, this create and allocate the memory of the node. You are going to do inside here. Okay, inside your user defined function. So it will look something like this. See, new node equal to struct node star malloc size of struct node. Okay, and if new node not equal to 0, that means memory is not assigned to new node, then you don't move forward, directly write memory is full. Okay, if memory is allocated to malloc, okay, so new node is not equal to 0, then you are going to move forward. Okay, start doing this, or do one thing, take a screenshot of this flow. Come on, A batch students, take a screenshot of this flow because I have to see now B batch student screens, so I'll be stopping my screen. Okay, keep this screenshot for your reference. of how you are going to code, try to code. Okay, I'm not saying right or wrong. Try to code and get the answer. And if you face any problem in between, just let me know. Okay, my B batch students. Anybody done with delete? B batch students, anyone who have finished with delete part? Three.
Yes, ma'am. Almost done.
Okay. Raj, what is the error? Can you please present your screen? Let me see. Vijay, delete part is over by you. Done. You are saying yes. So delete, I suppose it is over for you. Raj, visible. Your screen is visible.
मैं रन करूं?
Hmm. Okay.
अभी देखना प्रोग्राम खुद ही टर्मिनेट हो जाएगा।
हाँ हाँ, क्योंकि गलती है प्रोग्रामिंग में। लाइन नंबर 167।
167 फ्री पीटीआर
जहाँ
करना
पे
था।
फ्री फंक्शन है ना,
हाँ मैम।
वहाँ पे Raj, the way you have written the code is slightly wrong. Okay, see, I'm saying slightly wrong, not entirely wrong. फ्री फंक्शन सही से लिखा है, ठीक है, फ्री, देन इनसाइड इट यू आर नॉट गोइंग टू गिव द डेटा मेंबर वैल्यू, यू आर गोइंग टू गिव द पॉइंटर, ओके, पॉइंटर हु इज पॉइंटिंग टू द मेमोरी एड्रेस। सो वहां पे प्री टेम्प ही आएगा, प्री टेम्प ऑफ डेटा नहीं आएगा।
ओके मैम।
अभी रन करके ट्राई करो।
इसको टर्मिनेट करना पड़ेगा। टर्मिनेट हो गया।
अभी भी कहीं गलती है तो ये हेड ऑफ नेक्स्ट इक्वल टू प्री टेम्प ऑफ नेक्स्ट क्यों लिखा है वहां पे? अपडेट क्यों करवा रहे हो?
ओके
ओके, ओके ओके, मुझे याद है। एक मिनट, ये मैंने आप लोगों को बोला था, पता है, हिंट दी थी।
तो मेरे को भी अभी याद आया।
हिंट दी थी मैंने, याद करो। हिंट नंबर 1 आपकी ये थी कि हेड ऑफ नेक्स्ट इक्वल टू फ्री टेम्प ऑफ नेक्स्ट सही चलेगा जब आपके पास दो नोड्स होंगे, राइट।
हाँ मैम, ये
लेकिन हिंट नंबर 2 ये भी थी कि आपको एक थर्ड पॉइंटर लेना है जब आपके पास लिंक लिस्ट में मोर देन 3 नोड्स है। याद आया?
हाँ मैम याद है। हाँ
हाँ, तो चलो हिंट पे काम करो, चलो।
हाँ, कर रहा हूँ मैं। स्क्रीन प्रेजेंट बंद कर दो ना।
वो सही है, हेड ऑफ नेक्स्ट इक्वल टू फ्री टेम्प ऑफ नेक्स्ट सही ही है, लेकिन एक थर्ड पॉइंटर भी आपको इंट्रोड्यूस करवाना है। अब वो आप कैसे इंट्रोड्यूस करवा रहे हो वो आपका काम है, देख लो। ठीक है,
यस
विल
मैम।
डिस्कस, कम टू दिस पॉइंट।
यस मैम।
You can stop presenting, Raj. Thank you. Vijay, present your screen. Visible.
मैम इज इट
वो दो
विजिबल?
while loop ले ली। Number 6, delete before. विजय, डिलीट बिफोर का नहीं किया है क्या, या चला नहीं?
मैम ये मैम 2 वाइल लूप लगेंगे इसमें?
नहीं, अपना लॉजिक समझाओ कैसे किया है डिलीट बिफोर। एक्सप्लेन योर लॉजिक।
मैम जो प्री टाइम की वैल्यू थी वो मैंने है ना T1 में स्टोर कर रखी है, तो T1 से पहले का जो लिंक है वहां तक पहुंचूंगा वाइल लूप से, और फिर प्री टाइम के पहले वाले को है ना टाइम से लिंक कर दूंगा ऐसा।
ओके, लॉजिकली ट्राई करके देखा था पेन एंड पेपर पे कि ऐसा अगर
यस
ये
मैम।
कोड एग्जीक्यूट कर रहे हो तो ऐसे चल रहा है।
यस मैम, करा था try तो।
ओके, गलत नहीं है, सही किया है।
यस मैम।
ठीक है, लेट्स सी व्हाट अदर्स हैव डन, देन आई विल डिस्कस माय पार्ट। गुड विजय, कमेंडेबल जॉब। एनीवन एल्स फ्रॉम बी बैच जिसने ये हिंट पे काम किया हो?
मैम कैन यू प्रेजेंट?
श्योर प्रांजल। A batch students, you should focus on your work, okay? We have to come equal to B batch. So little bit hurry. Pranjali, you are showing me the code for removing the first node, is that so?
Now because
Pranjal, your voice is breaking. Your voice is breaking. You can write by commenting there only. Don't need to go back to the meeting screen. Just do // and write. Are you showing me the code for removing the first node? Okay. Then there will be changes. Yeah, the very first thing which I spotted is delete temp at your line number 16. There is nothing in C which commands delete temp. Okay, we are dealing with your DMA, and in your DMA, if you want to free up, delete means what? You are freeing up your memory, right? Discarding the unwanted values. Fine. So in your DMA, there is a free function. So instead of delete, you are going to use free function. Okay, delete temp won't be coming. There will be free, and inside the bracket temp will be there, or the pointer which you want to free. So you have to correct that. Then Pranjul, you should also write your else statement also. If head is equal null, return null. Okay. Fine. Whether it's not needed as such, but it is good if you write the else part. Node star temp equal to head. Head is equals to head of next. Yeah, rest of the things looks fine. Why are you writing void push? What is this push function doing? Run your program, Pranjal. Pranjal, if you are saying something, then your voice is breaking. You better write in the chat. Pranjul, your screen has stuck. I cannot see anything after implicit declaration of function free. Do one thing, stop presenting, run your program. If it runs correctly, do tell me. If you are facing any issues, then again mention in the chat, I'll come back to you. Okay, A batch students, done or not? Okay, Vijay, I'll come back when we are discussing that. A batch students, done with your insertion? You're not able to insert the data? Have you written your printf scanf statements, Shri?
Yes.
Show me your screen.
Okay, ma'am. Ma'am, is it visible?
Yes. Go to your function, insert ascending order, that function. Okay, you forgot to wait. Yeah, you forgot to link your new node data. See, after while loop, while temp data greater than new node data, okay? Pre-PTR equal to temp equal to temp of next. If this condition is false now, then what? Then afterwards you need to write, no? That where it has to link and where it has to delink, that portion is left yet.
Oh, okay, ma'am.
हेलो मैम, और इसमें while loop में भी
Yes, ma'am.
temp
I
of
got it.
data is greater than new node data किया, less than आएगा वो, new node बड़ा है उसमें.
राज, आप कैसे भी ले सकते हो, ऐसा नहीं है कि मैंने न्यू नोड लिया है, न्यू नोड ग्रेटर देन टेम्प डेटा, तो आप वैसे ही ले सकते हो. योर लॉजिक कैन बी डिफरेंट, एज आई सेड. आप कुछ भी ले लो, लेकिन आंसर लास्ट में सेम होना चाहिए. अगर आप टेम्प डेटा को कंपेयर कर रहे हो न्यू नोड डेटा से, तो थोड़ा रिवर्स होगा. क्या होगा कि 10 ग्रेटर देन 20 ऐसा हो जाएगा. तो अगर 20 आपका न्यू नोड है, हाँ, तो लेकिन आपको उस हिसाब से आपका लॉजिक भी तो अल्टर करना पड़ेगा ना.
ओके, यस मैम. अगर फॉल्स हुआ तो while loop के अंदर जाएगा ही नहीं ना.
एग्जैक्टली
तो फिर वो
वही तो बोल रही हूँ कि
temp पे
लॉजिक
जाएगा.
आपका है. वही बोल रही हूँ राज कि लॉजिक आप जो भी लगाओ, एंड रिजल्ट सेम ही आएगा.
यस मैम.
इसीलिए तो मैं अपना अपना प्रोग्राम देखो स्टूडेंट्स, व्हाई आई एम टेलिंग यू द वेरिएशंस, बिकॉज not in just this subject, in your every programming subject you will find variations of programs. Okay, end result would be same. Suppose for example you are going for swapping. Okay, तो किसी ने स्वैपिंग तीन तीन वेरिएबल से किया होगा, किसी ने दो से किया होगा. ओके, बट एंड रिजल्ट इज व्हाट, द करेक्ट स्वैपिंग. Okay, so there will be differences like this, but then you have to make sure that you alter your flow. Okay, do not mix up both the things, that you follow the condition which is given by you, or say you are choosing the condition and you are mixing up with my flow. If you do that, then it is wrong. Okay, so you have to take care of these small things. Okay, A batch students, Vidhi.
Yes, ma'am.
That was not there
No, ma'am, I'm facing issue even in the last code.
in the last code. Show me a screen.
Yes, ma'am.
Visible. Where is the error, Vidhi?
Uh, ma'am, see, it's coming like this.
My network is a bit slow. You have
Ma'am, I have
scrolled.
a doubt.
You have scrolled down.
No, ma'am. It's my output screen.
Vidhi, compile your program. Let me see what is the error.
Ma'am, I did. It's my output screen.
Wait, I lost my connection. Okay. Enter your data. Enters. Okay. There are some issues only in entering the data. Is that so?
Yes, ma'am.
Okay, so you are facing issues in the very first part of your program, that is creating your SLL. Okay, fine. Uh, Close this. Go up. Need equal to temp equal to new node. That is correct. Temp of next. Temp equal to new node. That is also correct. Go up. While I is equals to 1. Run your program. Enter the data. Not like this, not like this. This is the problem, not like this. You have to enter the data one by one. Give enter. Would you like to add more nodes? Yes. Give one. Again enter the data. Again give one. Okay, now give next. When you are asked, give 0. Okay. Fine.
Yes, ma'am.
Working?
Yes, ma'am.
Ma'am, I have a doubt.
Yes, Tushar.
Ma'am, the code at the very beginning, we are asking the insertion at the beginning only. So why we are using the switch case as an insert at the beginning? Because when I am using at the board screen, it's creating very complication. It's making the program very complicated.
The thing is, Vidhi, you can mute yourself, please.
Yes, ma'am.
Thank you. And you can stop your presentation also. Tushar, see, the thing is what? We have to first of all create a single linked list in order to perform all those six operations. Okay, because those six operations are performed with a constraint that your singly linked list is already existing. Okay, and in that existing singly linked list, you are making changes either by inserting the node at the beginning or deleting the node at the beginning or inserting or deletion at the end or in between. Okay, so that's why that code is written. Now if you don't want to include that, would you now, as you are very much familiar with the flow of that particular part of code, okay, then what you can do is instead of asking user again and again, would you like to add more nodes, would you like to add more nodes, okay, instead of what you can do inside a variable. Okay, this is another part. Okay, this is another way of creating your singly linked list. Okay, this is not the same way. Another way is what you take just a single input from the user as to how many nodes the user wants to create. Okay, let's say user entered that input as 4. Okay, store that 4 in one variable and run a for loop. Okay, here we are using while loop, and again at the end of entering the data you are again asking, do you want to enter more, do you want to enter more, okay, in that while loop. Instead modify that loop, modify that while loop, okay, to for loop. Now in for loop what you have to do, you have to create only those many nodes which the user has entered the number. Suppose user is entering 4, then your for loop should run 4 times, entering 4 nodes. Okay. Then at that particular point, you don't have to go and ask the user, do you want to add more nodes? Do you want to add more nodes? You can modify your program like this. Okay, for the sake of simplicity.
Ma'am, but
Yes,
if
Tushar.
I start the program with directly switch case and the beginning of the function which I have the insert at the beginning, I can use it in the switch case. Then I don't have to give the singly. I don't have to create the new node at the very beginning also, no? Because
Yes,
both the things are
but
doing
then what will
same thing
happen?
only.
See, I know, but the way of inserting will be a little bit of different. See, I'll present my screen. Batch A students, if you have finished with your ascending order, you can move forward and try out delete the first node of your singly linked list. You can try it out. Meanwhile, I'm discussing it here. See, Tushar, this is your linked list, okay? This is your linked list, fine. Now, what you are saying is you already have insert at the beginning, fine. So you can use that function call again and again whenever you want to insert. What will happen when you go and try to run that insert at the beginning? Okay, the way of inserting the node right now, how the nodes are getting inserted: head value, node value, next this one, next this one, next this one. Okay, like this. Okay, so it is in forward direction, or you can say one by one after the another. Here, one after the another. This one also one after the another. If you use that insert at the beginning function, what will happen? It will go on adding in this backward direction. Okay, how? 30 will be your first node, then 24 will be added, then 20 will be added, then 18 will be added, then 10 will be added. Okay, are you getting it, Tushar?
Okay, ma'am.
It is not wrong. What you are saying is absolutely right. You can use that. The difference between them I wanted you to see. Okay. When you are creating your singly linked list, you are going in this direction,
No,
in
ma'am.
forward
No,
way.
ma'am.
Okay.
No, ma'am. When I'm using the very first part of the beginning, insert your new node one, and then I'm
Hmm.
calling the function one. It is not updating the list, and I'm displaying again. It is not updating the list. The problem was that because it is not the
Okay.
doubly
Now
linked
it's
list,
clear.
we can go forward and backward and insert it. If I've started
Correct.
using insert at the beginning, it will traverse with beginning. If I've started from the end, it will traverse from the end only. No, it is not a
Yes.
doubly linked list. We have a double connections.
That is why doubly linked list and circular linked list are having advantage. And that is what you are going to see in your practical number 10.
And I was asking that only because when I was using the very first part of the function code and the insert at the beginning, I have the either option. Yeah, so I have to use the first one. Yeah, so I have to use insert at the beginning one. It wasn't working like that only.
Okay. Now it is clear, Tushar?
Yes.
Okay. See, students of A batch who are stuck in between somewhere. Okay, I'm just going through the code for you. See, first of all, go and create the allocation of the memory. That is what we have discussed. Alright. Fine. Sorry. Okay, so memory has been created here at line number 74. Then what we are doing, we are following that algorithm. If you remember, step number 1, 2, and 3. If avail is equal to 0, write underflow. Avail equal to avail of next. So that is all things we are checking here. That if new node got some memory address, then go forward. But if new node is only not getting memory address, okay, new node is not getting any address, then the else part of this if, inside that you are going to write printf memory is full. Okay, see else part. Memory is full. That is what you are going to do. Okay. Suppose let's say it is our good scenario and new node did get some memory. Okay, then what you are going to do, the very first thing, take the input for the newly created node. So you are taking the input new node data, okay, with the help of your printf and scanf statement. All right. Now what we have to do, we have to traverse in order to place this newly created node within our singly linked list. Okay, so in order to traverse, we know now it should be, hardwired in your minds that when I say traversal, that means there will be some pointer who is moving around in my singly linked list. Alright, so let's take a pointer that is called temp here. So temp is equals to head. Now in my while loop, the condition which I have taken is what? Temp data is less than new node data. Okay, till my temp data is less than my new node data, I have to move forward. So in moving forward, I'm taking two pointers. Now see here I am giving pre-temp equal to temp. Okay, and temp equal to temp of next. Alright, so this is the traversal part. This whole while loop is what? Your traversal part. Once this condition is false, temp data is no more less than your new node data. Okay, then what you have to do? Start linking and delinking. First, link pre-temp of next equal to new node. Okay, so link it. So we link this. Now, new node of next is equal to temp, right? So we linked new node of next equal to temp also. So this is done. We have placed our node in between and it is in ascending order. Got it? Students of A batch. Yes or no? Okay. Let me run this program. enter the data. Let's take this example only, keeping this example in the mind. We will enter the data. Okay, so 10, 18, 24 and 30. Okay, so 10, 18, 24 and 30. Alright, that is my existing single linked list. Now what I want to do, I want to insert node in ascending order. So number 3. Okay, it is asking me enter the data of the node to be inserted in ascending order single linked list. So what was the data here? 20. Okay, so 20. Do you want to continue? Yes. Now I'll go for display, that is number 5. See, 20 inserted in between my 18 and 24. Okay. For the ease of your user, at the end of this ascending order, you can write one printf statement stating that node has been inserted. Okay. Then you can go for want to continue and then continue with the flow. So 20 is inserted in ascending order. Clear, everybody? A batch students, yes or no? Okay, so now we are moving forward to your next algorithm, that is delete the first node. We are done with your insertion 3 cases. Okay, now we are going for 3 cases for delete. Okay, delete the first node of your linked list. Alright. So we'll take this example only. Now what we want to do, we want to delete it. Anyone has idea from a batch how we are going to delete this first node? This is the target node. Anyone would like to share their ideas on how you are going to delete this node?
I might have an idea.
Yes, go ahead. Share
Like
it.
first we will move the pointer to the next node, and we will free the memory. It's just that simple.
Exactly. See, what you are going to do is now, I'm removing this, okay? And this too. See, what we are doing now, we are going for delete your first node. Okay? So this is our target node to be deleted, students, A batch. Okay? B batch students, you can also concentrate here if you have missed any time. Okay? Delete first node. Alright, this is our target node to be deleted. So what all changes will come? First change, my head is no longer going to point to this 100 memory address. Okay, but it has to now point where? Here at this node. Okay, so that is one change. What is another change? This whole block will be freed up. Okay, that is the another change. So total 2 changes should be there in order for me to identify that my function has correctly and completely done. Okay, so let's go for it. First of all, you are going to take one temporary pointer. Okay, so ptr equal to head. All right, now you have to move your ptr. Okay, so ptr you can write here while PTR of next, okay, is not equal to your null value, okay. Or simply what you can write, even if you don't write this while loop, you can just give PTR is equal to head, okay. PTR is equal to PTR of next. Okay, let me show you logically first, then we'll go with the coding. You took your PTR equal to head, now you move your PTR, okay. So PTR is right now at 100. Alright, now how we are going to move it? With the help of this particular section, this particular headline here. You are going to move your head. Okay, PTR remains as it is, you are going to move your head. Alright, so because we want this head to point here. Fine. So move your head. You gave PTR the value of your head, now move your head. Now if I want to move my head here, okay, how am I going to do it? With the help of this value. Okay. So head is equals to head of next. So this head which is right now pointing at 100, when I go and update that value, head equal to head of next, it is going to point where? At 118. Okay, so what you did, you moved your head. Alright. This head is now pointing here. This PTR is pointing here. Okay. Fine. Now what you need to do, you need to free up this PTR because this PTR is now ready to free this memory. So call your free function. If you call your free function and inside that you are passing your parameter as PTR, okay, then what your free function is going to do, the memory which is, you know, consumed by this PTR, okay, that particular whole memory will get deleted. Okay, and the remaining singly linked list is what? Even this PTR won't be now pointing towards 100. It will be a null value for PTR. Okay, and see, still your singly linked list is existing. Head pointing at the first pointer now. Okay, last pointer is null. So what you have to do? Delete first node. Yes, Tushar.
Ma'am, do nodes get deleted or they just change the head?
No, the space, the memory space is getting freed up when you call your free function.
Okay, okay.
Head you are moving forward.
So that node has been cleared all deleted. The node has been
Correct.
deleted. No?
Correct. If you don't move your head, okay, if you don't move your head, before moving only, see, before moving your head, you are calling your free function, free PTR, okay. You will say that I did not pass head there in my free function, I passed PTR, okay. So when this free function is getting called, okay, then what will happen? This particular, before moving your head, okay, I'm explaining you the scenario. Before moving the head, you are freeing up this much, okay, you are freeing up this memory here. Obviously the memory is delocated, okay. So this PTR is now null because you passed that in your free function. But head is pointing at 100, but there is no memory called 100 here because that memory is now delocated. Okay, so again there will be an error because head is not pointing anymore to the first node, which is ideally 118 in our case. Okay, so before freeing up, you need to move your head and then go for the free function. So this is how you are going to write. First of all, go and check, does your singly linked list exists? You're going to again follow those 10 steps. In a switch case, go and add a case. Okay, delete at the beginning. Alright. So and then in your user defined function, check, does your single linked list exist? Because if head is equal to 0. Okay. So if it is true, then your single linked list does not exist. You cannot go for deletion. Else, follow the steps. Temp equal to head. Okay, move your head forward to the second node, that is head of next. Tell the user which value is getting deleted, okay, by printing your temp data. Okay, and with the help of your DMA free function, free up your memory. Okay, and students again, yes, Aditya, it does mean that when you operate a free function, that memory will be delocated. Okay. Students, see, so far I have seen screens, various screens, and still many of you are not writing the necessary comments. Okay, wherever it is necessary. So please do not forget to write comments. And again, I'm saying this is not particularly just for DS subject or C language. It is applicable to each and every language, whether you are using C sharp or Python or C++, anything, Java, anything. Okay, keep a habit of writing comments. It will not only help you in future, but it is also going to help your teammates in your companies if you are aspiring to work in the companies as software developers. You will be, a valuable member because you are writing your comment there. Okay, and everybody does not have to run for you that, okay, just tell me what you are doing here in this program. Okay, because your comments are self-explanatory, alright? So you don't need yourself to explain your programs. And that is the reason. This is for your long term. Okay. Okay, students of B batch, were you able to work on your hints? Yes or no, students of B batch, were you able to work on your hints? Okay. Darshan, was it successful or facing any errors? Okay, let's see your screen. Present your screen. Okay. A batch students, complete this delete at the beginning quickly. If you are done, then just tell me. Darshan, your screen is visible. Yes, yes, Darshan, it is visible. Let me just analyze your else part, okay? Darshan, is it working correctly?
Yes, ma'am.
Run your program. Create a single linked list with 5 nodes. 5, okay?
Yes, ma'am.
Done. Now do one thing. 10, 20, 30, 40, 50, 60. Okay. Go for delete before. So command 5. Alright. And enter the value before which. Okay. Go for 50. So I want 40 to be deleted. Alright. Give yes. And now go for display. Where are the other nodes? After 10, 20 and 30 should be there, no? So it is not running correctly. That was the hint part which you had to work on. And that's why I told you to take a third pointer.
Thanks.
Okay.
Okay.
Okay, we'll discuss it. Do not worry, do not worry. We'll discuss it. See, what the problem is, if in your singly linked list, there are 3 nodes, okay? Instead of 6, there are 3 nodes, okay? And you are choosing the second node to be deleted, then this logic is absolutely correct. Okay, it is going to give you correct answer. But if your singly linked list is more than 3 nodes, okay, then it is not going to work. All right, that
Okay.
was your work, your task to figure out or say to generalize that in any given condition where singly linked list is having more than 2 nodes or say 3 nodes, then also it should work. Okay.
Yes, ma'am. Right.
All right. Um, Students of A batch, are you done with delete in the front? Yes or no? A batch students. Aditya, Anuj, Ayush, Devansh, Girish. Oh, Girish is not a Manav, Nikita, Patrick, Smith, Tushar, both. Vidhi, done or not? You are getting some errors. See, I'm presenting my screen. Just verify your program. Okay. Again, this is kind of a bit spoon feeding. Okay, which I don't really prefer. But okay. Aditya, you need to show your screen then. Present your screen. Visible. Go in your compilation error logs down there. Scroll your window. I don't want to see the warnings. Go down. Is there any error? Any red color line? Just check. In that error log only, Aditya. Go to the very beginning of your program, very beginning, the first line. Okay. See, you missed to include one library called stdlib.h. We are dealing with dynamic programming, so you have to compulsorily include that library. stdlib.h. This library includes your dynamic memory functions. Okay, malloc, calloc, free, realloc. They are all defined in this library. So do not forget that. Now compile your program again. Let's see if there are errors or not. There are still some errors. Implicit declaration of insert at the beginning. Okay. Can you scroll down your error log? Don't scroll your program. Scroll your error log. Scroll it still. Okay, there is one error. Wait. What is it? Pretemp is undeclared. Pretemp, dear, it's your pointer. Have you declared that pointer anywhere? At line number 126, it is telling. You need to declare your pretemp. So you must have not, you must have missed that. So wherever you have declared your temp, pointer temp, star temp, there go and add star pretemp. That will be in your global declarations. See, you have written struck node star temp. Similarly, you can do one comma there. You don't need to write that again. Do one comma and write star pretemp. Okay, now run your program. Let's see if the wait, don't run. Okay, your program has started running. This enter data is for what? For creating your single linked list. Okay. Done, Aditya. Program working. Okay. Students of A batch. Done with your delete at the beginning. Okay, Vidhi says yes. Apart from Vidhi, from A batch. Quick students, quick. You are going too slow. We cannot afford to be slow. This was the easiest deletion. Delete at the beginning. Just move your head and free up your PTR. That's all. Nobody apart from Vidhi. Devansh, you are from A batch. Where have you reached? Where have you reached, dear? Deletion is done. Okay. Depend. Deletion is done. Delete at the beginning. Students, see, you need to acknowledge something so that I can come to know that whether we are on same page or not. Okay, and if you don't do it quickly, it is very time consuming and time of rest of the students is getting, engaged there. Okay, now students of A batch and B batch, both pay attention. A batch students, we are discussing your another case here, okay? And B batch students, we are discussing the hint part. Alright, so I'm trying to get both the batches on equal page now. Okay, so I'm presenting my screen again. Which case we are discussing? We are discussing the case where we have to delete in between. Okay. ABAC students, do not worry. We are not omitting this one. Okay. We are going to do it, but first we'll cover this delete node after a specific position. Okay. So what we are going to do, first of all, we have to delete the node after a specific position. Alright, let's say this is my singly linked list. Okay. What we want to do, we want to delete after a specified position or say data. Alright, so first step is what? Take the specified data. Okay, so step number 1. Take the data. After which you want to do the deletion. Okay, let's say that data is storing, I am storing it in some num value. Okay, so let's say num I am giving as 20. Okay, so after this I want deletion. After this means what? Which is my target? My target is this PTR. Okay, so in order to reach your target here, what you are going to do? You are going to compare the data part of each. Okay, that is what you are going to do in your coding also. See here. Wait, we are doing delete. Okay, this one delete before the specified position. Okay, so my mistake, not delete after. We are doing this delete before. Okay, sorry, my mistake. So let's say now I don't want to demonstrate you with this 20. Wait, because then it will delete this one. Fine, let's keep it 20. Okay, no issues. Alright, so we are going for delete after, not after here, it is delete before. Okay, before the specified data. So 18 is my data which is to be deleted. Okay, or I can take here, let me just do it in a complex way. Okay, so 1, 2, 3, 4, 5, and 6. Okay, and the number which I'm going to take for which I want to delete is, let's say, 30. Alright, so if I say 30 is the number before which I want to delete, then obviously this is the node, 24 is the node which is to be deleted. Is my screen visible?
Yes, ma'am.
Yes or no? Okay. Alright, so this one is our node to be deleted. Alright, so let's go. Now what we have to do? Compare your numeric value. Alright, we have to traverse inside this my singly linked list so that we reach here. Once we reach here, we can free up this previous node. Okay, so what we are doing in traversal part, alright, while PTR of data is not equal to your num. Okay, so you are going to take one PTR equal to head. From the very first node, you are going to compare your numeric value. Alright, PTR of data. So first iteration, 10. 10 is equal to 30 because 30 is the node, right? Num value. So 10 equal to 30, no. So what I need to do? Move my PTR and pre-PTR. Okay, so again, pre-PTR is equal to my PTR, okay, and PTR is equal to PTR of next. All right. So this here there will be pre-PTR, okay, and this PTR is now here. Now again, PTR of data 18. 18 not equal to 32. What I need to do? Move again. So this pre-PTR moves here. This PTR moves to next part. So here again 20 not equal to 30. Okay. So again move pre-PTR is here. PTR moves to this part. Okay. Here. Now PTR is what? 24. 24 not equal to 30. Alright. So PTR here is pre-PTR is going to move forward. PTR moves here. Now. Okay. Now PTR data 30. 30 not equal to 30. This is false. Okay, 30 not equal to 30 is false. So we are going to stop. So see what are the current positions of your pre-PTR and PTR. Pre-PTR is at our target node which is to be deleted. Okay. PTR is at the node before which we want the deletion. Okay, so some of you might think that okay, now we have reached our target node. 24 was our target node, so we can just free up this pre-PTR with the help of free inside bracket pre-PTR. That is okay. That is the step we are going to do. But then what about this node? This node which is pointing at 90, this 90 is getting freed. So it should point here at this particular node. So this instead of 90 there should be 210 here, right? Right or wrong? Students, the question is for you. If I am freeing up this one, where should this 205 point at?
210.
Exactly. And how can you access this part of 205?
By address using.
You have to take a third pointer. Okay, you are going to take one third pointer. That third pointer will be one node behind your pre-PTR. Okay, that was your hint for this. This I am talking for B batch students. I told you that you are going to take a third pointer. Okay, so that third pointer, what you are going to do is you are going to give the value of that third pointer here after every iteration here.
Pointer equal to pre-PTR, no?
Yes, so that temp is equals to pre-PTR in such a manner that your temp will be say one node behind your pre-PTR. Okay. Why we are taking this third temp? In order to access this value, so that we can write a statement something like this: temp of next. Okay, we are accessing that value, this one. Temp of next is equal to PTR. Okay, once we execute this line of code, this statement, what we are doing, we are updating this 90. From 90, we are updating it to whatever memory address PTR is at. Okay, so that is 210. So what we did actually, we just delink this from 90. Okay, and now this node is pointing here. All right. Now you can free up. See, as we delinked, this pre-PTR is no more linked with its previous node. Okay. So once you free up this pre-PTR, it will look something like this. Then you can execute your free function. Okay. And your singly linked list logically will be looking something like this. So see, now it is okay. Okay, it is in singly linked list format. If I correct this one a little bit. Okay, it is here. This arrow and this one. Okay. So see, you have done it correctly. Your 10 is at here. Okay, this is a singly linked list. You removed 24 from between. ABAC students clear with the logic. Ask the user before which the data they want to delete. Alright. Compare it by traversing inside your singly linked list. So PTR of data not equal to num. But here, along with pre-PTR equal to PTR, before giving this command, you have to write here, before this pre-PTR equal to PTR, you have to write here, temp is equal to pre-PTR. Okay? That you have to write. Fine? Why we are writing this line before? Because we want temp to be one node behind. Okay, and you can point your PTR and your pre-PTR at the very beginning, and that means equal to head. Like this, you can point them both. Okay, so your temp is going to remain here, and then gradually it will be behind your PTR and pre-PTR. Okay, now be back students. I told you hint number 1 changes is in this line. Hint number 2, take third pointer. Okay, so you have to take third pointer here. Temp equal to pre-temp. Okay, and here temp is equals to head and pre-temp is equals to temp. Okay, I have taken temp here already. Okay, then this will be temp, let's say temp 0. Okay, and do not forget to declare that temp 0. Otherwise, you will get errors again. Okay, so temp 0 is equals to pre-temp equal to temp, and temp is temp of next. Alright. Now what you have to make changes here. You have to write, instead of head, you have to write temp of next is equal to pre-temp of next. Okay? Or if you don't want to write this pre-temp of next, then another way is what? Temp of next is equal to your temp. This will be temp 0, my mistake again. Okay, what is this temp 0? This one. Okay, so temp of 0
pointer before
is
three
equals
pointers.
to PTR, or temp of 0 is equals to pre-temp of next, because we are yet to free up our pre-temp. Okay, so you can either write it like this or like this, anyway. You can write, there are two ways to write, you can write either of them. It is correct. Alright, A batch and B batch students, understood?
Yes, ma'am.
A batch students, we are going to keep your session till here. B batch students, solution for your last session already discussed here right now. So we are going to start tomorrow. Tomorrow you have lab with me again. Okay, so B batch students, we are going to start with next case. You have to finish this case. Okay, it should run properly. If it is not running properly, just tell me what are the errors. In few minutes of time initially we'll discuss those errors. Okay, we'll try to solve that, and then we'll move forward to our last case, that is delete after. Okay, and A batch students, we are concluding your lab, we are keeping your lab till here. In your next week session we are going to see one case, that is delete after. Okay, which is your last case, delete after the specific position. All right, and then we'll implement this practical 8 also. Okay students, clear? Instructions to everyone. The instructions are clear. Okay, we are concluding our lab here. Thank you all for attending the lab sessions.